Welcome to another geometry lesson. I'm Mr. Pi, the math guy. Today we're going to be talking about geometric probability. Let's get this math party started. Just a real quick review. The probability of an event is the favorable outcomes over possible outcomes. When you talk about geometric probability, there are two kinds. A model in which you let points represent outcomes is a geometric probability. We can use segments, then we can represent that probability as the probability of event is equal to the length of the favorable segment over the length of the entire segment. Another geometric probability is with area, and we can define that as the probability of an event is equal to the favorable area over the entire area. So we're going to see how to use both of these kinds of geometric probabilities to solve problems. Here in example 1t, we're told that a fruit fly lands at random on the edge of the ruler below. Find the probability that the fruit fly lands on a point between 5 and 9. So working with the probability, we're working with the probability that the fruit fly is going to land on the ruler between 5 and 9. So this is a probability. And we want the point between 5 and 9, so we could write that down as this. The probability of between 5 and 9. Now that's going to be the probability of the length of the favorable segment. And the length of the favorable segment here is 5 to 9. Now we could count that 1, 2, 3, 4, or we could subtract it going 9, take away 5. Over the total segment, we could count that again. 0 to 10 would be 10, or 10 take away 0. So the favorable distance is 4, and the total distance is 10. Now that, of course, reduces to the fraction 2/5. 4 divided by 2 is 2. 10 divided by 2 is 5. We can express that as the decimal point 4, or the percent 40%. There is a 40% chance that a fruit fly will land somewhere between 5 and 9 on this ruler. Here in example 2, we're told that a museum offers a tour every 45 minutes. If Gino arrives at the tour site at a random time, what is the probability that he will have to wait for at least 15 minutes? Here we're going to use a number line where we're going to find the probability of the length of the favorable segment over the length of the total segment. So here's going to be our line, and we're going to divide this up. This would be 0, and we're going to go increments of 5. So that'd be 5, 10, 15, 20, 25, 30, 35, 40, and 45. So there we have our segment. We can shorten this up. And so we have our segment there. And every line represents 5. So 0, and then 5, and then 10, 20, 30, 40, and the last line being 45. So if we're talking about the probability that he'll have to wait for at least 15 minutes, so the probability that the time is going to be greater than or equal to 15 minutes. And in this case, the time being greater than or equal to 15 minutes is going to be a length of 15 up to 45. And that'd be 45 take away 15 over the length of the whole segment, which would be 45 minus 0. And that's going to give you 30 over 45, which is equal to 2/3, because they're both divisible by 15. 30 divided by 15 is 2. 40 divided by 15 is 3. And that's going to be approximately 67% chance that he's going to have to wait 15 or more minutes. In example 3t, we're given a circular archery target has an 8-foot diameter. Find the probability of hitting each colored region. So we have four colors in here. We have red, green, yellow, and blue. So we're going to have to find the probability of hitting each. To do that, we're going to have to find the areas of each section because this is a geometric probability. We're going to have to find the area of the blue circle, which is pretty easy. Let's start breaking this problem down. We're told that it has an 8-foot diameter. So if we think about the diameter, that's the distance all the way across. And if we go from here and count 1, 2, 3, 4 being the center, 5, 6, 7, 8, the diameter here is 8 feet. When we work with area, we are concerned with the radius. So here, the circular target has a radius of 4, and we're going to go by looks here, and it looks as if they're equally divided. So each one of these has a distance or a width of 1 foot. And that would make the radius of the blue region 1 foot, the radius of this region, the blue and the yellow, 2 foot, the radius of the blue, the yellow, and the green, 3 foot, and the radius of the blue, the yellow, the green, and the red, 4 feet. So with that in mind, we first have to figure out all of the areas so then we can find the probability. So let's go ahead and start looking at how to find the areas. Finding the areas here, you see I already have written down the area total, the area of the blue, the area of the yellow, the area of the green, and the area of the red. The area total is the total area, which is going to be the denominator of our probabilities. So the area total is going to be the area of a circle with a radius of 4. 1, 2, 3, 4. So that's going to be 4 squared pi. We're just going to leave it in terms of pi right now, and you're going to see why. This ultimately becomes 16 pi. Now the area of the blue region is simply the area of a circle with a radius of 1. So the area of the blue is equal to 1 squared pi, which becomes pi. That simplifies to pi. Now the area of the yellow region is really the area of a circle of radius 2, subtract the area of a circle radius 1. To figure out the area of the yellow, we have to figure out the total area of the yellow and the blue and subtract away from it the area of the blue. Well, we already know the area of the blue is pi. So here, the area of the yellow is equal to the area of the yellow plus the area of the blue, and we have to then subtract away from it the area of the blue. So to do that, the area of the yellow plus the blue is the circle of a radius 2, so it'd be 2 squared pi. We have to subtract away from that, not equals, but subtract away from that the area of the blue, which is calculated as pi. And when we do that, that'd be 4 squared, or 2 squared, which is 4, to give 4 pi minus 1 pi, which gives 3 pi. So the area of the yellow is 3 pi. Calculating the area of the green, the area of a green, that ends up being a circle of a radius 3 minus the area of the yellow and the blue. So we have to do the area of the green plus yellow plus blue. We have to subtract away from that the area of the yellow plus blue. Well, the area of the green plus yellow plus blue is the area of a circle, radius 3, so it'd be 3 squared pi minus the area of yellow plus blue, and we know the area of yellow plus blue is 2 squared pi. Well, 3 squared pi is 9 pi, and 2 squared pi is 4 squared, or is 4 pi. When we subtract those, that gives us 5 pi. So the area of the green is 5 pi. Now here's a pattern. 1 pi, 3 pi, and 5 pi. When we find the area of the red, we could go through these calculations, or there's a pattern here that it's an increasing odd number, so the area of the red is equal to 7 pi. Now that's how I could use the pattern here. If we do the actual work, the area of the red is equal to the area of the red plus green plus yellow plus blue, the area total, minus the area of the green, the yellow, and the blue. The area total is the area of a circle with radius 4, which we already know is 16 pi from here, minus the area of green plus yellow plus blue, which we did over here is 9 pi. And 16 pi minus 9 pi is 7 pi. Now that we have the areas done, we can move into calculating the probabilities. Moving on to the probabilities, much like I had the areas, I have set up the probabilities in the orders I'd like to do them. I'm going to start with the probability of the blue region now. Remember, the probability is the favorable region over the area of the entire region. That's why you have this total area up here. And the area of the blue region is pi. So when I go to write this out, the favorable region is pi. And the total region is 16. So the probability of the blue is pi over 16. Now the pi's divide out, leaving us 1 over 16. Now that's something you can do on a calculator. That's something you could do by hand. If you do it on a calculator or by hand, that converts to the decimal, 0.0625. And that is the percent 6 1/4. So there is a 6 1/4% of hitting the blue. Moving on to the yellow. The area of the yellow region is 3 pi. The total area is 16 pi. That becomes the fraction 3 over 16 because the pi's cancel out. Dividing that out, that gives us 0.1875 or 18 3/4%. The probability of hitting the green area is going to be 5 pi over 16 pi, or just 5 over 16 because those pi's will divide out. When you divide that out, that is 0.3125 or 31 1/4%. The probability of hitting the red region, that's this last region, the outer ring, is going to be 7 pi over 16 pi, which is just 7 over 16. And when we divide that out, that gives 0.4375. And that, of course, is 43 3/4%. So there is using geometric probability, in this case specifically the area of a circle, to calculate probability.